Hello and welcome to this AQA Statistics video, Discrete Random Variables 3, this time looking at one-tailed tests for the mean of a Poisson distribution. So you might like to pause a moment and just read this through. We have a scenario where we know an average that has existed, and that's selling 6 houses during the month of October, so we have an average for a particular time period. And we have some information that this October he has only sold 2 houses. And we need to carry out a hypothesis test to see whether there's evidence that the mean number of houses sold during October has decreased. So we're going to be looking at the evidence that we have got to see whether we can conclude that there has been a change in the mean. And we're going to be looking in this video at a one-tailed test, and that will either be looking for a definite increase, or in the case we're looking at, this example, we're looking for a definite decrease. And we are going to test this at the 5% level, so it's always important to take note of your significance level for every test and see whether at the 5% significance level there is evidence that the mean has decreased. And what we need to look at is whether the fact that only 2 houses were sold gives us enough reason to doubt the fact that lambda may still be 6. And so we are just going to be looking at one tail of the distribution, the probability of getting 2 sales or fewer, when the average we're still assuming is going to be 6. And how likely is this result to happen? Is it less than 5% likely to happen, in which case we would doubt the null hypothesis, or is it a perfectly likely event to occur even if lambda was still 6? So setting up the hypotheses formally, we need to think of our null and alternative hypotheses. And remember, our null hypothesis will always be a statement, and in this case for a Poisson mean it will be a value for lambda, and of course this is lambda equals 6. And our alternative hypothesis in this case is not greater than, it's going to be, is lambda less than 6, has lambda decreased? And we are going to be looking at the evidence we've got to test this hypothesis. So always check for the word in the scenario you're given, because that will tell you what sort of tail test you're going to be using. So we've decided on our null and alternative hypotheses for this particular example. We know that we are going to be testing at the 5% level, so we are looking to see whether the probability of getting 2 or fewer sales is equal to or less than 5%. And that's because we're told that only 2 houses were sold in this particular October. And we're going to be looking at the probability of obtaining 2 or fewer sales when the average would be expected to be 6. And we're looking at a Poisson model. So here we have our hypotheses. We've made note of the significance level. We know that our random variable follows a Poisson distribution where lambda is 6. We know we only had 2 houses sold, and finding the probability of 2 or fewer houses being sold, that left-hand tail, the probability that you can obtain from a calculator or from GeoGebra comes to 0.062. And that's what it would look like if you use the calculator. And we now need to compare this outcome to the significance level of the test. and so we're going to be looking at 0.062 and comparing it to the 5% level of significance. And of course 0.062 is greater than 0.05. So that particular event, the probability of getting 2 or fewer than 2, will happen more than 5% of the time, even if the mean number sold is still equal to 6. So we don't quite have sufficient evidence to definitely reject our null hypothesis, and we would then state our conclusion that there's not sufficient evidence to suggest that the number of houses sold on average in October has decreased. So here is another example, and it would be a good idea, I think, at this stage to pause, read it through, see if you can work out the value of lambda that is being suggested as the usual value, see if you can work out your hypotheses, see if you can identify whether we're looking for an increase or a decrease for a one-tailed test, identify your significance level, and identify the probability of the extreme value or less or more that you're looking for this particular problem. So first of all, hopefully you realize we're talking about modeling with a Poisson variable, mean lambda, where lambda equals 4. On average, she has 4 colds each year. And she starts a new job, and in her first year gets 8 colds, which is obviously greater than 4. So is there some evidence to suggest she has more colds? So we're looking at whether there's an increase. We're told it's the 10% level. With the null hypothesis, lambda equals 4. We're interested in 8 colds happening. That's much higher than normal. So we're going to be looking at the tail, which is greater than or equal to 8. And then going through the whole procedure, the probability of getting greater than or equal to 8. So we're looking at this top tail here. What's that probability? And the probability comes to 0.0511, so just over 5%. And we were testing this time at the 10% level, so we've decided that our cutoff point is 0.1. If the probability of an extreme outcome is 0.1 or less, we're going to reject the null hypothesis as being too unlikely. If it's greater than 0.1, we're going to accept the null hypothesis. And this time our probability, 0.0511, is less than our significance level. So in terms of what we are testing under here, we're going to say that's very unlikely, and we will reject the null hypothesis. And we do have evidence to suggest that on average she's caught more colds than usual this year at the 10% level of significance. And that's the end of this video.